Welcome to today's class, and we are going to be solving question on electric field 2 part B, where we discuss electrochemical electrolysis and the discharge tube. So let's solve question on electrochemical cell first, then we'll solve question on discharge tube, then we'll take electrolysis, because most questions on electrochemical cells and discharge tube, they are not calculation based. So we are going to do electrolysis last. So the first question: which of the following components is not contained in a dry cell? When you hear the dry cell, we know we have 5 types of cell: Daniel cell, Leclanché cell, which is dry Leclanché cell, wet Leclanché cell. We have the less acid accumulator, and we have nickel ion accumulator. So they are referring to dry Leclanché accumulator. And when you check A, B, C, D, they are all contained in a dry Leclanché cell, apart from copper rod. So copper rod is not part. And what's the function of this one? To avoid polarization. So this is the electrolyte. If you use the electrolyte, if you use the solution of ammonium chloride, that will be wet cell. That's wet Leclanché cell. For the second question, which of the following is stored by a Leclanché cell? All cells, all those 5 cells mentioned, they all store chemical energy. That's why they are called electrochemical cells. So the energy in them, the potential energy stored in them, is chemical energy. So when they are connected to external circuit, that's when they drive current. So the chemical energy stored is going to be converted to electrical energy. So the function of the system of granulated carbon mixed with what? Manganese 4 oxide, that is MnO2 plus carbon in a Leclanché cell is to dash, is to prevent polarization. I even said it here. So it's to prevent polarization, which is the formation of hydrogen bubbles on the what? Zinc plate. So next, which of the following factors has no effect on EMF of primary cell? Temperature has effect, because the more the temperature, the more the resistance, and the more resistance, the more the what? EMF. So temperature has effect. The next, size of the cell doesn't really matter. What matter is the electrolytes and the electrodes. So nature of the plates, yes, these are the electrodes, they count, they have effect. Nature of electrolyte, yes, it has effect. So the answer is what? Size of the cell. The size of the cell doesn't matter. Next, a simple cell with mercury amalgamated zinc electrode prevents what? It prevents local action. Recall we explained during last class that local action is a way of what? Of the electrode due to the presence of impurities on the zinc plate. So in order to prevent local action, what we did is to clean the zinc plate with sulfuric acid, then rub it with what? Mercury, and that's what we call amalgamation, to prevent local action. Next, which of the following has the lowest internal resistance? Definitely accumulators. Accumulators have what? The lowest internal resistance. So because they give out the largest what? PD. So for example, Daniel cell give 1.1 volts, Leclanché cell 0.5, accumulator 2.2. So for a constant current, it means this one has the least what? Resistance from Ohm's law. Next, the suitable cell used for short interval switches in electric cells, in electric bell is, so if you need short interval switches, then we don't need IPD. So pick the answer which gives us the lowest PD, and the answer is Daniel cell. The Daniel cell gives us the least PD, which is 1.1 volts. So Daniel cell will be suitable for a short interval switches, because if the PD is low, we can what? Maintain the short interval switches in electric bulb, for example. Next, a newly charged 12 volt accumulator can easily start a car, whereas 8 new dry cells in series with an effective EMF of 12 volts cannot start the car. So if we have an accumulator, maybe it's nickel ion or lead acid accumulator, 12 volts can start the car. But if we have 12 volts and they are what? Normal cell, dry cell, they cannot start the car. Why? The reason mean that if we have dry cells in series, they all have internal resistance, and their internal resistance will increase. So from Ohm's law, V equals to IR, then I equals to V over R. So if the internal resistance is very high, the current will be low. So if current is low, they cannot start the car, because we need high current capacity to start the car. So the accumulator can easily start a car because the current capacity is high. The answer is A. Whereas all these 12 volts cannot start the car because their current capacity is low. But all these options are referring to the accumulator. So the answer is A. So these are what common questions on electrochemical cells. Now let's go to discharge tube, then we'll come back to electrolysis. Okay, here we have questions on discharge tube. Number one, cathode rays are what? I said on last class, streams of electrons. Number two, which of the following describe cathode rays? They consist of tiny particles of negative charge. Yes. They are deflected in a magnetic field only. No, they are also deflected in electric field. They consist of fast moving neutrons. No, they contain no neutrons, only electrons. So the answer is I only. Next, a gas will serve as an electrical conductor under, obviously, under low pressure and high PD. But the pressure of a gas is very low, extremely low, like 1/1000 of normal atmospheric pressure, and the PD is high, about 5000 plus, then it will what? Ionize, then it will conduct. The charge carriers in gases are, the answer is the electrons and ions. Because when those gases are under low pressure and high PD, they ionizes and they become ion, and electrons what? Streams of electrons from the cathode to the anode, while the positive ions move from the anode to the cathode. So the answer is the electrons and ions. So ions and no. Hydrogen ions are for electrolytes. Electrons and holes are for semiconductors. So electrons only are what? Metals, while electrons and ions for gases. Next, the ray which causes gas molecules to glow is cathode ray. Very obvious. In a discharge tube, most of the gases is pumped out so that the electricity is conducted at. So this question says, what is the essence of what? Pumping out the gas is to reduce the pressure so that the electricity is conducted out at low pressure. B. Although when you check option D, it says at low pressure and high PD. This is more correct than B. But for this particular question, they are focused on why the gas are pumped out. So if gas are pumped out, the pressure is low. So they didn't tell us anything about PD. So we know the answer, we know that high PD is also correct. But based on what they asked in the question, we have to focus on why the gas are pumped out. Is no. The last thing, under which of the following conditions do gases conduct electricity? Obviously D. Low pressure, high voltage. Question on discharge are very direct and simple. Now let's go to electrolysis, where most of the questions are calculation based. Now, questions on electrolysis. In an electrolysis experiment, a cathode of mass 5 grams is found to weigh 5.0 grams, meaning something has been deposited on it. So the mass deposited on our cathode will be different between this and this. So if you do 5.01 minus 5, we get 0.01. So this is the mass of the substance deposited. After a current of 5 amperes, I is 5 amperes, flows for 50 seconds, T is 50 seconds. What is the electrochemical equivalent of the substance? EC, that's Z. So electrochemical equivalent is also what? Z. Find the first law of electrolysis, M equals to ZQ. M equals to ZQ is IT. So Z definitely equals to M divided by IT. So the electrochemical equivalent Z equals to mass 0.01 over the current 5 amperes time 50 seconds. From here you get the electrochemical equivalent to be 4 times 10 minus 5. What's the unit from here? Z equals to gram over what? Coulombs. That's grams per coulombs. Sometimes it can mean kilogram depending on the unit of mass. Next, in a copper plating, the current of 0.5 amperes is allowed for cathode area of 100 centimeters squared if this current is maintained for 100 minutes. Time is 100 minutes. The thickness of the copper deposited would be, we are looking for the thickness, we are given the electrochemical equivalent to be 0.0003 grams per coulomb, and we are given the density to be 104 gram per cm cube. In this case, we don't need to convert the units except for the time, because coulombs in terms of ampere seconds, so the time must be in seconds. Now, since the area is centimeter and the density is what? Gram per cm cube, the mass will be left in grams, volume or area or thickness will be in centimeter, but the time must be in seconds. So 100 minutes times seconds, so it means the time equals to 6,000 seconds. So what are we going to use here? Normally m equals to zq or m equals to zit. When I do mass, you know mass is density times volume. And what is volume? Area times thickness. We did this in our last class. So we are looking for thickness, that's what zit over rho a. It's actually there in your notes if you have a complete note. Thickness equals to electrochemical equivalent 0.0003 times the current 0.5. The time, we are given 100 minutes, but it must be in what? Seconds, so multiply by 60. The density 104, then the area 100. So the press, you get a thickness in centimeter as. So the thickness will be 8.65 times 10 to the power minus 5 centimeter. But it's very close to micro. Next question. The electrochemical equivalent of the metal is 0.126 by 10 to the power minus 6 kilograms per coulomb. The mass of the metal that a current of 5 amperes from a suitable bath deposit from a suitable bath with in 1 hour times 1 hour, and 1 hour is 60 minutes. 60 minutes is what? 60 seconds. That's 60 times 60. So we are looking for mass. So just use n is zit straight. Z 0.126 times 10 to the power minus 6. Current is 5. The time is 60 times 60. So at the end, the mass will be next. A charge of 1 coulomb, that's Q. 1 coulomb liberates 0.0033 grams of copper in an electrolysis process. That's mass 0.033 with 2 zeros, 33 grams of copper. How long will it take a current of 2 amperes to liberate, So in this case, this is actually like a variation. And here we are dealing with mass and what? Q. So remember, N ordinarily is ZQ. It is Q that is IT. From here, Z is constant. Z equals to M over Q. And this means that M1 over Q1 equals to M2 over Q2. So M1 is given to be 0.0033. Q1 is 1 coulomb. You are looking for M2. Now, how long will it take? So you are looking for time now. You know that Q2 is IT. Say IT2. So we are given M2 to be 1.98. So this is 1.98 divided by Q2. But Q is IT, so an I is 2. That's 2 times the T is what we are looking for. From here, if we multiply, if 2 multiplies this, we are having 0.00660 equals to 1.98 times 1. Then from here, we can get the value of T by dividing both by this. And T equals to 1.98 divided by 0.0066. We get our T in seconds to be 300 seconds, which we can convert to minutes by dividing by 60. 300 by 60 will give us 50 minutes. Next question. The electrochemical equivalent of platinum is 5 times 10 to the power minus 7 kilograms per coulomb. To electroplate out 1 kilograms, means if the mass is 1 kg, a current of 100 amperes is needed. 100 amperes is needed. Sorry, a current of 100 amperes must be passed through an appropriate vessel for forming the length of time for how many seconds. So, same formula, M is ZIT. Then T is M over ZI. I think you can finish this by yourself. So that is 1. The mass is 1. Equivalent is 5 times 10 to the power minus 7. And the current is what? 100. So we should be having 10,000 over 5, and that's 20,000 seconds. We can convert it to, hour. So to go to hour, you divide by 60 twice. 20,000 over 60, that will be minutes over 60, that will be an hour, and that will give us 5.56 hours. Next, the electrochemical equivalent of a metal is 1.3 times 10 to the power minus 7 kilogram per coulomb. The mass of the metal, which 2 times 10 to the power 4 coulomb of electricity will deposit from a suitable electrolyte, is simply M equals to ZQ. So just multiply 1.3 times 10 to the minus 7 times 2 times 10 to the power 4. You get the answer there. Next one. 118.8 centimeter squared, that's area. 118.8 cm squared. Of copper cathode of a voltmeter is to be coated with 10 to the power minus 6 meter thickness. The problem here is in centimeter, this is meter. So the best is we should convert this one to centimeter. So from meter to centimeter, we multiply by 100. So meaning this same thing as 10 to the power minus 4 centimeter. So we multiply meter by 100, we get centimeter. Of copper, of density, we are doing density, but density is given in what? Kilogram per meter cube. So the density of copper is due to be 9 times 10 to the power 3 kilogram per meter cube. We can decide to convert this one to gram per cm cube. From kilogram per meter cube to gram per cm cube, we divide by 1000. When you divide by 1000, you get 9. That will be density. How long will the process run? We are looking for time. With 10 amperes constant current is 10 amperes. What are we going to use? M equals to ZIT. And I think we should be given the electrochemical equivalent of copper. Without it, we cannot move on. Then from here, M is rho V, ZIT. Our volume is area times thickness, ZIT. Our aim is to get T, and T from here is what? Rho AX over ZI. So the time equals to density, that's 9. Area 118.8, thickness 10 to the power minus 4, current 10 amperes. What about the electrochemical equivalent of copper? It should be given in the question. In the question, it is given as 3.3 times 10 to the power minus 7, and the unit is kilogram per coulomb. Now the problem is, in our solving, we are using gram and centimeter squared. So we cannot use kilograms here. So we have to convert this one back to what? Gram. So if the ECE for copper is 3.3 times 10 to the power minus 7 kilogram per coulomb, then we need to convert this to gram per coulomb. What's kilo? 10 to the power of 3. So meaning we are going to multiply this one by 1000, and that will give us 3.3 times 10 to the power minus 4 gram per coulomb. So we are going to use minus 4 here instead of minus 7. Please, you have to be very careful. So when density is in gram per cm cube, every mass should be in grams, every length, area, or volume should be in centimeter. Length centimeter or thickness centimeter, volume centimeter cube, area centimeter squared, and every item must have gram. So if you press this in your calculator, you should get 32.4 seconds, and in minutes, if you divide by 60, it will give you 0.54 minutes. 0.54 minutes. And last question, if a current of 2.5 amperes flows through an electrolyte for 3 hours and 1.8 grams of substance is deposited, what is the mass of the substance that will be deposited if current of 4 amperes is passed through for the time now 4.8 hours? This is like a variation case. You can call this one I1, T1, M1, M2, I2, T2. So M is ZIT, and Z is constant, Z is M over IT. From here it means M1 over I1 T1 equals to M2 over I2 T2. Then from here, if you continue, our aim is to get M. So you can make M the subject of the formula. So if you make M the subject of the formula, I mean M2, so M2 equals to M1 with this, that's M1 I2 T2 over I1 T1. So let's input the values. What is M1? 1.8. What is I1? I2 rather 4. T2 4.8. We don't have to convert the time. Why? Because no matter the unit, as well the unit is the same, they will cancel each other. Over what is I1? 2.5. And T1 is 3. So by the time you press this in your calculator, you will get M2 to be equals to 4.6 grams. So this will be the end of ElectricField 2, both part A and part B. Then our next class, we are going to move to electrical instrument, the manometer, ammeter, voltmeter, potentiometer, Wheatstone bridge, and meter bridge. Then also solve question. Then after that, we'll now move to ElectricField 4, where we are going to talk about simple AC circuits.